Hello everyone, welcome to 2.3 day 0. And if you haven't grabbed a highlighter yet, you're going to want to do that. So quick reminder that at any time during the video, you can press the spacebar to pause. And throughout, I will be asking, especially when we get to some of the practice, to press pause and give it a try and then check answers with me. So remember the shortcut to do that is the spacebar. Notice the title of today's notes, Factoring Out Greatest Common Factor Notes and Other Vocab. And we have a key list of vocabulary here that's really going to frame our entire conversation in these next couple of lessons. So it's super important our language is common and understood. So let's get started with our first definition of a term. Perfect example of a word we use all the time, but what does it really mean? A term by definition is, or are, terms are parts of an expression separated by addition or subtraction signs. So for example, if we were to put an example right here, if I had 3x squared minus 5y plus 6 plus 10xy cubed minus 7x, and I asked you, how many terms is this? I would want my brain to focus in on everywhere I see an addition or a subtraction sign, because again, by definition, terms are parts of an expression separated by addition or subtraction signs. So that means we have 1, 2, 3, 4, 5 terms total here. A monomial, let's highlight our next definition. A monomial is an expression with one term. And we might be using some deductive reasoning for our next definition as we increase our count here. A binomial is an expression with two terms. A trinomial is an expression with three terms. And then over here off to the side, let's define a polynomial. Polynomial is an expression with four or more terms. So we really only have names for 1, 2, or 3 terms. Past 3 terms, they are grouped into this general vocabulary word of a polynomial. Next definition on our list is that of a factor. Again, a word we use all the time. What does it mean? A factor is a number, or factors are numbers or expressions that multiply together to get another number or expression. We have an example right here. 5 and 3 are factors of 15 because 5 times 3 is 15. We could do our own example here underneath. Let's say factors of 12. We actually have several sets, right? We have 2 and 6, 4 and 3, and 12 and 1. So we would describe this as 3 sets of factors for the number 12. Let's now talk about what is a greatest common factor, or GCF. We understand the meaning of factor, so what is the greatest common factor? The greatest common factor is the greatest or largest number. I should actually say value instead of number. Largest value that divides exactly or evenly into 2 or more values. And I changed the word to values. We could have also had said terms, because this could be with or without variables, variables with it. So that GCF could just be a single number, a constant term, or it could be a constant and a single variable with it, or a constant and multiple variables. So it's the greatest or the largest value or term, single term, that divides exactly or evenly into 2 or more values or 2 or more terms. If we were to just look at this numerical example of 12 and 18, we're looking for the largest, the greatest or largest value that divides evenly into 12 and 18, and that would be 6. Does 2 divide evenly into 12 and 18? Yes, it does. But 2 is not the greatest common factor. It's a factor, but it's not the greatest common factor. Let's now answer this question. What will it mean to factor a polynomial? And we're going to want to highlight this question, because when we see this direction in our practice or in a homework or on a quiz, we really want to understand what we're being asked. So when you're asked to factor a polynomial, this means break apart an expression by finding two factors that multiply to the original. It will essentially be undistributing. A little contrast here, so this step stands apart from what we just wrote before. So to factor is to break apart an expression by finding two factors that multiply to the original. It's essentially undistributing, so you're breaking it apart into smaller pieces. We have two examples written for us here. X plus 2 and x minus 4 are factors of x squared minus 2x minus 8 because, notice, when you multiply these together, you arrive at your original. 3x and x squared plus 5 are factors of 3x cubed plus 15x because when you multiply those two pieces together, right, like redistribute, so to speak, this is the undistributed version. When you distribute, you arrive at your original. So let's see how this is going to work. Let's start practicing some together. For questions 1 and 2, it asks us to identify the GCF. My recommendation is to always pay attention to the the whole numbers first, or the numerical coefficients first. We have 24, 48, and 64. So we have two coefficients that are numbers, and then we have a constant term. Pay attention to the numbers first. So I'm asking myself mentally, 24, 48, 64. What is the largest number that goes into 24, 48, and 64? The answer is 8. So in terms of identifying, we're not actually doing any work. It just said to identify. So I know 8 is going to be part of my answer. Now I'm looking at the variables. R cubed, R squared. There is no R term right here, so we are done. The GCF is just 8. Let's try number 2. 35, 20, 10, 50. Largest number that goes into 35, 20, 10, and 50 is 5. Now I'm looking at the V terms. I have V to the 10th, V to the 6th, V to the 4th, V to the 3rd. Here's the key. You want to take the same number of V's from each of these terms. So the way that I think about it is imagine you had 4 friends that each had a certain amount of money. This friend has $10, this friend has $6, this friend has $4, and this friend has $3. You want to take the same amount of money from each friend. So this guy, who has the least amount of money, is really determining what you can take from all of your friends. Like just because this person has $10, it doesn't matter. This person only has $3. So you can at most factor out V to the 3rd. You can at most take $3 from each person if you're going to take the same amount of money from each person. So our GCF here is 5V cubed. So to emphasize our steps, take a look at the numbers first, then take a look at the letters. And if there's more than one letter, or if there's more than one variable, do them one at a time. Let's now practice actually factoring out the GCF. So for number 3, I'm looking at 6, 54, 36, and 60. 6 can be factored out of each of these. So now I'm going to set this up with division bars underneath each term, and I'm at a minimum, I'm factoring out 6. Now let's take a look at the A's. I've got A cubed, A squared, A. This term does not have an A value at all here, so I cannot factor out any A's. Our GCF goes outside our parentheses. Remember, we are undistributing. The opposite of distributing, or the opposite of multiplying, is dividing. So you're literally dividing out this GCF. What's left? 6 divided by 6 is 1, so I've got 1. You didn't take out any A's, or we didn't divide out any A's, so A cubed is still there. 54, a positive 54 divided by 6 is a positive 9. A squared stays. Negative 36 divided by 6 is negative 6. That A stays. And then plus 10. And we are done. The way that you can always check your answer is mentally distribute your GCF back in. So if I were to mentally multiply 6 back to each of these terms, I should end up where I started. For emphasis, remember, factoring out the GCF is the opposite of distributing. You're factoring it out. You're breaking this up. We now have our two pieces, right? We have our GCF on the outside multiplied by this term. That's as far as we can go for that one. Taking a look at number 5, I'm actually going to do all the odds, and then I'm going to ask you to pause and try the evens, and then we'll check answers together. Okay, so looking at number 5, we have 9, 54, 63. I know that I can factor out a 9, so I'm going to set up my division. So I can take out 9, that means a division. Now I've got y cubed, y squared, and y. You want to take the same amount of money from each friend. This friend only has a single dollar, so we can only factor out a single y. GCF goes outside, parentheses. Let's do it. 9 divided by 9, 1. Y cubed divided by y. You had 3 y's here. You're factoring out a single y. Y squared remains. Another way to visualize that, y cubed literally means y times y times y. You're dividing by a single y. Any value divided by itself cancels, so a single y cancels out, and notice y squared remains. Moving forward to the next term, negative 54 divided by 9 is negative 6, so minus 6. There were 2 y's, you're factoring out a single y, so 1 y remains, or y to the first remains a single y. 63 divided by 9 is 7, positive 7. There was a single y, you're dividing by it, so these cancel. Close your parenthesis and you are done. Number 7, 12m to the 7th minus 18m to the 6th plus 30m to the 5th minus 6m to the 4th. Never let the size of the question here cause you to worry. The process doesn't change. So no matter how many terms we have here, let's always go back to that first starting point of looking at the coefficients. 12, negative 18, 30, negative 6. What can we factor out? At most, I can factor out 6, and each of these is divisible by 6. We have 7 m's right here, m to the 7th, m to the 6th, m to the 5th, m to the 4th. This friend limits you to factoring out m to the 4th. So we put 6m to the 4th outside parentheses, and let's see what remains. 12 divided by 6 is 2. You had 7 m's, you're factoring out 4 of them, 3 remain. 18, negative 18 divided by 6 is negative 3. You had 6 m's, you factored out 4, that leaves 2 behind. Positive 30 divided by 6, positive 5. You had 5 m's, factored out 4, 1 remains. Negative 6 divided by 6, negative 1. You had 4 m's here, m to the 4th. You factored out all 4 of them. None remain, so just minus 1 is right there. And notice having this minus 1 here as a placeholder is super important, because if I were to redistribute this, right, if that negative 1 was not there, you would have no way of getting back to this final term, right? When you send in that GCF, you should always arrive back at your original. So that placeholder at the end is super important. Number 9, 8p squared plus 20p minus 16. Taking a look at 8, 20, and 16, super tempting to maybe think about 8 as a GCF, but 20 is not divisible by 8. So let's think again. The largest value that goes into each of these is 4. This final term does not have a variable p term here, so we cannot factor out anything else other than 4. 4 goes outside our parentheses. 8 divided by 4 is 2. P squared remains. Plus 20 divided by 4 is 5. P remains. Minus 16 divided by 4 is a negative 4, and we are done. And the goal here is that we continue to practice these to the point where it just becomes more and more comfortable, and that comes with practice. Moving on to 11, negative 30x to the 4th minus 48x cubed plus 12x. Now, when we have a negative leading coefficient. Standard practice is normally to factor out a negative GCF. If you see something like this on Delta Math, be conscious of that. If it's saying it's not right, if there was a negative leading term, it might be expecting you to factor out a negative GCF. If you don't factor out a negative GCF, I won't consider that question completely wrong. Just recognize it is standard practice that if we have a negative leading term, we factor out a negative GCF. So looking at 30, 48, and 12. 30, 48, 12. Divisible by 6. The largest term we can take out is 6. So we're going to factor out a negative 6 from each term. X to the fourth, x cubed, and x. This friend limits us to factoring out a single x. So now we have negative 6x outside parentheses. What's left? Negative 30 divided by negative 6 is a positive 5. X to the fourth divided by x, x cubed. Negative 48 divided by negative 6 is a positive what? Positive 8. There were 3. You're taking out a single x. That leaves 2 behind. And then we have a positive 12x minus 6x. Ooh, wow. Let me say that again. Positive 12x divided by negative 6x. So 12 divided by negative 6 is negative 2. There was a single x. You factored it out. That's as far as we go. Last one before you press pause and try some on your own. Number 13, 20k to the fourth minus 14k squared plus 8k. 20, 14, and 8 is at most divisible by 2. So we can take out a 2 by means of division. Now we've got k to the fourth, k squared, and k, so I can factor out a single k. 2k goes outside our parentheses. We've got 10k cubed minus 7k plus 4 remaining. All right, your turn to practice. So please press pause and give the evens a try. When you press play, we will compare answers together. Please press pause now. And again, the shortcut for that is the space bar. Press pause now. Welcome back. Let's compare our answers. So for number 4, we have a negative leading term. So we factor out a negative 3x from both of our terms here. And there's our answer. Number 6 is the first example where we're looking at a case with 2 variables present. So remember to always look at those one at a time. After I decided that 7 was the numerical value I could factor out, this term has x cubed. This term does not have any x component to it, so we are not able to factor out any x's. I've got y squared present in each term, so I can factor out y squared, and here's our result. So if we need to, just press pause, even just for a couple more seconds here, to take a look at this one and make sure this one is fully making sense. And if it's not, please let me know. Send me a quick email, and we can chat about it. Number 8, I'm able to factor out a 10. There's my results. Number 10, I'm able to factor out 5v. There's my answer. Number 12 is a great example. Yes, we have 4 terms, but nothing to worry about. Our process doesn't change. I'm able to factor out 3n cubed, and then very carefully, term by term, decide what remains inside your parentheses. Take a moment to check each term and each sign. Watch the signs. And then last but not least, number 14 here. Great final example to take a look at. 6 and 2, I can factor out a 2. Once again, this is an example where we have 2 different variables present. So taking a look at the x terms first, I have a single x right here and a single x right here. That's like you have 2 friends. They each have $1. Well, you can take $1 from each of them. So I'm able to factor out a single x, and then y squared and y cubed. This friend has $2, this friend has $3. We can take 2 from each of them, so I can factor out y squared. So the complete GCF is 2x y squared, 6 divided by 2, 3. There was a single x, you factored it out. No more x term left here. There were 2 y's, you factored out both of them. There was y squared, right? Y times y, y times y. You factor out both of those y's. So 3 remains. 2 divided by 2 is 1. X divided by x is also 1. Y cubed divided by y squared is a single y. So if you wanted to, you could write 1 right there. That's completely fine. If you like seeing that value of 1 in front of the y. Or you could just write 3 plus y. Our class practice that you can work on with a partner right now is page 41, and I will post this practice page answer key in today's green folder so that you can check answers with me as well. After we finish that, we have a big set of classwork/homework practice that starts on page 42. If you're feeling really good with the GCF concept, you can skip page 42. So page 42, optional practice. Page 42 is optional practice. For the second part of your classwork/homework, we're going to focus on page 43 and 44. And we're going to be working on numbers 25 to 54. And you have a choice of odds or evens. So again, this was GCF, optional practice. Our task starts here with number 25. For the remainder of class, you're going to practice your distributing skills. So we spent a lot of time on GCF. We do need to remember how to distribute. So that goes back to using our arrows. For example, 8 times 2x is 16x. 8 times negative 8 is negative 64. Remember that to combine like terms, let me put the definition over here. Like terms, same variable, raised to the same power. So 64 doesn't even have x associated with it, so you definitely can't combine those guys. Let's take a look at one more example. Let's see, how about 33? So we're going to do a times a is a squared. A times a positive 2 is positive 2a. And now we need to send in negative 3. So negative 3 times a is negative 3a. Negative 3 times a positive 2 is negative 6. Like terms. This is a squared, this is a. They do both have a's, but this is raised to a power of 2. This is not. So my like terms here are positive 2a and a negative 3a. My final answer is going to be a squared minus a, or minus 1a, minus 6. And that's as far as we can go. Let's do one more together. Let's do 37. So we're going to do 2x times 3x is 6x squared. 2x times a positive 2 is a positive 4x. And then we've got negative 1 times 3x is negative 3x. Negative 1 times a positive 2 is a negative 2. Combining like terms, they're right here. So my final answer, 6x cubed minus x minus 2. Quick reminder on notation on 38. This means 2 of these guys. So 3v plus 3 times 3v plus 3, and then you can distribute as you would. So classwork/homework for the remainder of class is page 43 to 44. numbers 25 to 54, unless you want to work on these GCF questions too. That's optional. 25 to 54, odds or evens. So basically pick the left column or the right column. And what's really nice is on page 45. On page 45, you have the answer key. So as you're working on your classwork/homework, you are able to instantly go check your answers, either one at a time or a column at a time, whatever you prefer. Nice job, everyone. Have a great rest of your day.